Just be a little introduction to the unit circle. So the unit circle is helpful when you are evaluating trigonometric ratios. So in a trig course, you might very well have a full-blown unit circle page that you are able to refer to. If you get to the point where you're taking calculus, you're probably going to be responsible for computing some of those trigonometric values on your own without necessarily just ripping them right off of that formula sheet. So that's what we'll try to talk about here. So the two most important aspects of the unit circle: it is a circle centered at 0, 0. So a lot of people forget that the unit circle is actually in the coordinate plane. If you don't remember that the unit circle is positioned in the coordinate plane, it's really not that useful to you. The other important characteristic is that the radius of the circle is 1 unit. So I'm going to plot a standard position angle. So a standard position angle is always going to start along the positive x-axis, and if it's a positive angle, it's going to open counterclockwise from the x-axis. So I'm just going to kind of plot an angle within the first quadrant here. So I'm going to call that angle theta. And if you think about what I just did when I plotted that angle, I connected it from the origin, which is where the circle is centered, to the outer edge of the circle. So that segment is definitely going to have 1 unit in length. So I see the opportunity to do something else, and that's to drop straight down to the x-axis from that location and create a right triangle with this little stretch of the x-axis. So we have a triangle now popping up within the unit circle. If you think about the coordinates of this point right here, the coordinates of this point generally can be represented as x comma y. I did that because I wanted to find a way to label the rest of this triangle. It's definitely a right triangle. If this point has coordinates x comma y, the distance I'm coming across the x-axis until I'm just below it right here, that's got to be x units. And the distance that I'm rising up into the first quadrant to get to that point has to be y units. So check out what I can do with a little bit of right triangle trigonometry, a little bit of SOHCAHTOA. If I apply the cosine ratio to this triangle, I need to reference the angle that I'm working with, which is theta. So cosine of theta, well, cosine from SOHCAHTOA has to be adjacent divided by hypotenuse. Adjacent divided by hypotenuse simplifies to just an x. So what we've just determined is that the x coordinate of this point right here is actually equivalent to cosine of the standard position angle that we've plotted. If we do a similar calculation with sine of theta, sine is opposite divided by hypotenuse. Opposite the angle theta, we see a y. Hypotenuse, we see a 1. Opposite divided by hypotenuse is y divided by 1. That simplifies to just a y. So what we've just done a derivation to show is that any spot on the unit circle is going to have coordinates cosine of theta, comma sine of theta, since x is equal to cosine of theta and y is equal to sine of theta. So we'll go ahead and we'll do a couple quick examples just to show how useful this result is. So let's say we wanted to try to compute cosine of pi. So if you're trying to compute cosine of pi, you do need to know how to locate that. Sorry about that, out of focus there. Let me see if I can fix that. That should have worked. We do need to know how to locate this angle on the unit circle. So we need to start by plotting that standard position angle. So cosine of pi. Well, the conversion factor between radians and degrees that you're hopefully familiar with is that pi radians is equal to 180 degrees. Oops, sorry, working up above where you can see. So if I'm plotting a 180 degree angle or a pi radian angle starting on the positive stretch of the x-axis, that's going to put me right here. Cosine of pi corresponds to the x coordinate of that point. That's what we said when we did this work on this other page, right? The x coordinate is given by cosine of the angle, or the x coordinate gives cosine of the angle. Well, you should know what the coordinates of that ordered pair are. It's on the circle. The circle has a radius of 1. We're on the x-axis, but we haven't moved up off of it, so the y-coordinate is 0, and that means the x-coordinate's got to be -1. Cosine of pi is that x-coordinate. So that's it for cosine of pi. Done. We used the unit circle to get that answer. Do a couple other examples here. So let's keep that conversion factor here. Don't know why I erased it. Could have just left it there in the first place. Let's quickly try to do sine of 3 pi by 2. So when you're trying to locate this angle, that might be a little confusing. Here's how I like to think of it. This pi has two things happening to it. It's being multiplied by 3. It's also being divided by 2. Because there's no addition or subtraction going on here, and multiplication and division essentially happen at the same spot within the order of operations, what I'm going to do is I'm actually going to divide both sides of this equation by 2. I'm trying to turn this left-hand side into the angle that I see right here. So I'm trying to turn this into 3 pi by 2. Now, I've done the division first because my personal preference is to have this number of degrees get smaller before I multiply it by anything to make it bigger again. So pi divided by 2 is equal to 180 divided by 2. Well, 180 divided by 2 is 90 degrees. I need to go that amount 3 times around the circle, right? So I'm trying to form this 3 pi by 2 on the left side of this equation. So if I have 90 degrees here and I multiply that by 3, I've got to go 90 degrees 3 times around the circle. So one time going 90 degrees, a second time going 90 degrees, a third time going 90 degrees puts me down here. I should be able to rattle off the coordinates of that point. The x-coordinate is 0, the y-coordinate is negative, and it's dropped down 1 unit from the origin since it's on the circle, and the circle has a radius of 1. Sine, according to this work that we did a few minutes back, sine is going to sync up with the y-coordinate from a point on the unit circle, so sine of 3 pi by 2 is going to equal -1. We'll do one more in this video, and then we'll take a few more tougher examples in a separate video. So let's go with one that's a little bit tougher. Why don't we go with cosecant? We'll do cosecant of pi. So all of the work that we've been doing within this video has been involving the sine ratio or the cosine ratio. This is the first time we're seeing one of the other trig ratios. So if you have cosecant, secant, cotangent, tangent, what you're going to have to do is you're going to have to re-express your problem in terms of sine and cosine. The unit circle is only going to help you directly with sine and cosine. So you might remember the identity that says cosecant is the reciprocal of sine. So this is really 1 over sine of pi. I can get the answer for sine of pi from the unit circle. So let's go ahead, draw ourselves a circle, find the angle pi. Well, pi is equal to 180 degrees. We actually dealt with this a little bit earlier on in the video. So pi is 180 degrees. The coordinates of that point, -1 for x, 0 for y. I'm now in need of sine of pi. So I need to represent that with the y-coordinate from this point. The y-coordinate from that point, didn't really show up very well there, sorry. The y-coordinate from that point is 0. It's not showing up well at all. Let me try this. Let me try one more thing. I guess it's a little bit better. The glare's just in a different spot now. If you think about 1 divided by 0, 1 divided by 0 is an answer that is undefined. So when you deal with the other trig functions, whether it's cosecant, secant, cotangent, or tangent, those are all going to be expressed in terms of sine and cosine using fractions. So if your denominator of that fraction becomes a 0, then your result is going to end up being undefined. So I'm going to try to work on my lighting here, and then we will take a look at a couple other examples that are a little bit tougher and involve the 30, 60, 90, 45, 45, 90 ratios in a separate video.